In this tutorial, I'm going to do some assorted examples for solving different types of right triangle equations. For my first example, I've got a right triangle. It's not a 30-60-90 or a 45-45-90 triangle. In fact, it's a 35-55-90 right triangle. And what I want to do is I want to solve for x and y. The way I'm going to solve for x and y, I'm going to look at this angle that's 35 degrees, and compared to that 35-degree angle, this is the opposite. This is the hypotenuse, and this is the adjacent. I want to know what x is. Well, look, x is the opposite. I also know that 10 is the hypotenuse. Which trig function uses the opposite and the hypotenuse? Some old hippie. So the sine is equal to the opposite over the hypotenuse. The sine of what? The sine of 35 degrees is equal to the opposite, x, over the hypotenuse, 10. So how do we know what x is? We just multiply both sides by 10. X is equal to 10 times the sine of 35 degrees. What is 10 times the sine of 35 degrees? Well, I'm going to bring up my calculator. Make sure that you're in the degree mode. If you're in the radian mode, you're going to get the incorrect answer. So no matter what type of calculator you use, make sure you put yourself in the degree mode. And I want to do 10 times the sine of 35. And so I'm going to do 35, take the sine of 35, then I'm going to multiply that by 10. And what do I get? Approximately 5.7. Okay, so the value of x is approximately 5.7. Don't know what the units are, so I'll leave it there. Okay, how about y? Well, y is the adjacent. I know 10 is the hypotenuse. Which trig function uses the adjacent and the hypotenuse? Well, that's the cosine. So the cosine of 35 degrees is equal to y over 10. So y is equal to 10 times the cosine of 35 degrees. Once again, I'll get out my handy-dandy calculator. 35, I'll take the cosine. I will multiply that by 10. And this time, I get approximately 8.2. So the value of y is approximately 8.2. Not too hard, was it? Let's try example 2. Okay, once again, I've got a right triangle. It's not a 30-60-90 or 45-45-90 triangle, but I do know that the measure of one of the angles is 51 degrees. Compared to that 51-degree angle, the y is still going to be the hypotenuse, but now the 283 is the opposite, which makes x be the adjacent. In this case, if I want to figure out what x is, I know I've got to find the adjacent. I already know the opposite. Which trig function uses the opposite and the adjacent? Tryptophan acid, or TOA in the SOHCAHTOA. So the tangent of 51 degrees is going to be equal to the opposite, 283, over the adjacent, which is x. I've said many, many times that when I want to solve for x in this way, it's always the case that I can switch these two expressions, or in this case, these two numbers around. And so I'm going to get x is equal to 283 divided by the tangent of 51. Let's plug that in the calculator and see what happens. Oh, looks like I lost my calculator. Give me just a second here. All right, so I need 283 divided by the tangent of 51. And I get 229.2. X is approximately equal to 229.2. believe it or not, that's an approximate sign right there. How am I going to solve for y? Well, first I'll extend the page just a little bit so I've got a little more room. Y is the hypotenuse, and I know the opposite. What trig function uses the hypotenuse and the opposite? Some old hippie. So the sine of 51 degrees is going to be equal to 283 over y, which tells me that y is going to be equal to 283 over the sine of 51 degrees. See how easy that is? Let's plug that in my calculator. Notice that y is the hypotenuse. It better be more than 283. If I don't get a number bigger than 283, I've done something wrong. Let's see what it's going to be. Here we go. 283 divided by the sine of 51. Can you tell I'm used to using an 83 or an 89? I'm not real used to this calculator, but we're going to go for it anyway. I end up with 364.2 approximately. So y is approximately equal to, oops, I've already forgotten, 364.2. Example 3, let's see what we've got for example 3. It asks us to find the perimeter of the triangle. This time I'm only given one angle measure, and that's that I have a right triangle. I've got three sides. I'm going to have to use the Pythagorean theorem. Well, the x plus 3 has to be the biggest side. It's the one that's opposite the 90-degree angle. So let's work this out. I've got x squared plus x minus 3 squared is equal to x plus 3 squared. X squared is just x squared. What is x minus 3 squared? Hopefully you can do this without having to FOIL it out, but I'll go ahead and FOIL it out for us anyway. X minus 3 squared is x minus 3 times x minus 3, first, outer, inner, last. I get x squared minus 6x plus 9. So I've got x squared plus x squared minus 6x plus 9 is equal to x plus 3 squared. Well, what is x plus 3 squared? It is x squared plus 6x plus 9. If you have to FOIL it out, go ahead and do so, but in the end you should get x squared plus 6x plus 9. I'm going to combine like factors on the left-hand side, and I get 2x squared minus 6x plus 9 is equal to x squared plus 6x plus 9. Because it's a quadratic, I want everything on the same side, so I'm going to subtract x squared, I'm going to subtract 6x, and I'm going to subtract 9. If I have 2x squared minus x squared, that gives me x squared. I have a minus 6x, and I'm going to subtract another 6x. That gives me a minus 12x. I have a plus 9, and as I subtract a 9, that's going to leave me with 0. So in the end, I get x squared minus 12x is equal to 0. I need to factor x squared minus 12x. The thing I tell you to always look for first, is there a common factor between x squared and negative 12x? And the answer is yes. X is a common factor, so I can factor out x times x minus 12 is equal to 0. Well, if a product is equal to 0, then one of the factors has to be equal to 0. So either x is equal to 0 or x minus 12 is equal to 0, which tells me that x is 0 or x is equal to 12. The problem with x being equal to 0, if I try x equals 0, 0 minus 3 is negative 3. Well, that's not going to help me at all. That certainly can't be the side of a triangle. So this is an extraneous root, and I'm not going to worry about it. Okay. What about x equals 12? Well, if I plug in 12, this is 12. 12 minus 3 is 9. 12 plus 3 is 15. Holy cow, look at that. That's a 3, 4, 5 triangle multiplied by 3. 9, 12, 15 triangle. So I know the value of x, but be real careful. It didn't ask me the value of x. It asked me the perimeter of the triangle. How do I find the perimeter of a triangle? I just add up the three sides. So the perimeter is 15 plus 9 plus 12, which is 27, which is 36. Okay. So the perimeter of the triangle is 36 units, whatever those 36 units are. Example 4. The altitude of an equilateral triangle is 4 times the square root of 3. What is the area of the triangle? Well, let me try to sketch an equilateral triangle. My daughter will tell you I may not be the greatest artist ever known, but let's pretend that's an equilateral triangle. And altitude goes from a vertex perpendicular to one of the bases, and so now I have a 90-degree angle. Because it was an equilateral triangle, this has to be 60 degrees. Look what I have. I have a 30, 60, 90 triangle. One of the legs is 4 times the square root of 3. Is that the shorter leg, the longer leg, or the hypotenuse? It's the one that is opposite the 60-degree angle, so that's the longer leg. If I know the longer leg of a 30, 60, 90 triangle, how do I find the shorter leg? I divide by the square root of 3. Well, what is 4 times the square root of 3 divided by the square root of 3? It's just 4. And so the green part here is going to be equal to 4. Well, the altitude, notice the altitude was the angle bisectors. It's actually cut this segment into two congruent parts. If this part is 4, this part is 4. And so what is the base of my triangle? The base is 4 plus 4, which is 8. The area of a triangle is 1/2 the base times the height, or base height divided by 2. So in this case, it's 1/2 times 8, which is the base, times the height, which is 4 root 3. Well, half of 8 is 4, so I get 4 times 4 root 3. Well, what is 4 times 4 root 3? It is 16 times the square root of 3. The area of that triangle must be 16 times the square root of 3. I want you to try some on your own. I'm going to have you pause the video, and then I'm going to explain to you the answers when you get through. So go ahead and pause the video to solve for x and y. Okay, if I'm going to solve for x and y, I see that I have a 49, 41, 90 right triangle. Don't know a whole lot about that, but I do know that compared to 49 degrees, x is my opposite, y is my hypotenuse, and 24 is my adjacent. I want to know what x is. X is the opposite, 24 is the adjacent. Which trig function uses the opposite and the adjacent? Tripping on acid. So the tangent is equal to x over 24. The tangent of what? The tangent of 49 degrees is equal to x over 24. Gotta love it when the bell rings. You know what time I'm doing this. All right, so x is equal to 24 times the tangent of 49 degrees. What is 24 times the tangent of 49 degrees? Let's find out. We're going to round this to the nearest tenth. Okay. Oops, forgot what I was doing already. That's what happens when the bell starts ringing. So let's do the tangent of 49. There's the tangent of 49. What am I going to do with it? I'm going to multiply that by 24. Try to find the equal sign. Oh, boo. All right. Even worse. All right, so let's try it. Let me clear that out again. 24 times. Don't you love it when these things happen? All right. 24 times the tangent of 49. Ooh, that took a while, but we got 27.6, approximately 27.6. Okay, that works pretty well for me, because if this is 49, this is 41, 24 should be smaller than what x is, and x is 27.6. How about y? Y uses the hypotenuse. I know the adjacent and the hypotenuse. That's the cosine. So the cosine of 49 degrees is going to be equal to, what do we decide, the adjacent over the hypotenuse. So y must be equal to 24 over the cosine of 49. What is 24 divided by the cosine of 49? I don't know. Let's find out. 24 divided by the cosine of 49. Approximately 36.6. Okay, so y is approximately equal to, how can you forget things that quickly? 36.6 degrees. I'm hoping that this thing right here is an 8, because if it isn't, I'm off a little bit. If that's a 3, I might be off. But if that's an 8, it's 36.6 degrees. Okay? There's x and there's y. Problem 2, find the area of the triangle. Go ahead and pause the video and try this on your own. Okay, I'm going to use the Pythagorean theorem, and I'm going to say that x squared plus x plus 1 squared is equal to x plus 2 squared. Well, x squared is x squared. If you FOIL out x plus 1 squared, you'll get x squared plus 2x plus 1, don't know why I put a parenthesis there, is equal to x squared plus 4x plus 4. Make sure you don't give me x squared plus 4. Make sure you actually FOIL this thing out and get a middle term. Combining like terms, 2x squared plus 2x plus 1 is equal to x squared plus 4x plus 4. I'm going to subtract all of the things on the right-hand side. That's going 2x squared minus x squared is x squared. 2x minus 4x is minus 2x. And 1 minus 4 is equal to negative 3. So x squared minus 2x minus 3 is equal to 0. I need two numbers that multiply together to give me negative 3 and add together to give me negative 2. Well, the two magic numbers that do that are going to be negative 3 and positive 1. They multiply to give me negative 3 and add together to give me negative 2. So I can factor this as x minus 3 times x plus 1 is equal to 0. If a product is equal to 0, one of the factors has to be equal to 0. So x equals 3 or x equals negative 1. Well, if x equals negative 1, the side is negative 1. This has to be an extraneous root. How about x equals 3? If x equals 3, I have a 3, 4, 5 right triangle. That's pretty good. I should remember a 3, 4, 5 right triangle. But be real careful. It didn't ask me what x is. It says, what is the area of the triangle? Well, to find the area, I have to know the perpendicular. Here's the perpendicular. My base is 4 and my height is 3. The area of the triangle is 1/2 the base times the height, which is 1/2 times 4 times 3. Half of 4 is 2. 2 times 3 is 6. The area is 6 units squared, whatever the units are. Problem 3. Find the area of an equilateral triangle of side 7. Pause the video and try it now. I really wish that you would remember the formula for the area of an equilateral triangle. There's a formula that says the area of an equilateral triangle is square the side, multiply it times the square root of 3, and divide by 4. If you do that, you can easily see that the area of this equilateral triangle is 49 root 3 divided by 4, and you're done. Otherwise, we're going to actually have to draw an equilateral triangle. Assume I drew an equilateral triangle. Let's put this down. The side is 7, so half of this is going to be 7/2, and the altitude is going to be 7/2 times the square root of 3. Let's clear that out. That looks really, really bad. 7/2 times the square root of 3. Okay, so the area is 1/2 the base, which is 7. That's a 7, believe it or not, times the height, which is 7√3/2. So there is the 1/2. There's the base, 7, which is 7/1. There's the height, which is 7√3/2. Multiplying across, I get the area is equal to 49 times the square root of 3 divided by 4. If you remember this formula here, when we get to talking about the area of regular hexagons, I'll just tell you that a regular hexagon is made up of 4 equilateral triangles, and we'll just take this formula and multiply it by 6 to get the area of a regular hexagon when we know the side. Otherwise, hopefully we can do enough with these trig functions that we can get the answer anyway. Problem 4. Pause your video and try it now. Okay, an ant crawls 4 inches. Let me put my ant here. Pretend I drew an ant. Well, here we go. We'll put a little. Now he looks just exactly like an ant, doesn't he? Here we go. He's going to go 4 inches south, and then he's going to go 8 inches west, and then he's going to go 7 inches north. Oops, I kind of run into my thing here, right? 7 inches north. How far is he from the starting point? Well, let's look at this. Assume that I drew an actual segment with that green piece there, and I want to know how far or what the length of this segment is. How far, let me try a different color, how far over did I go? Well, clearly I went 8 units over. How far up did I go? Well, this whole segment here is 7. If I subtract the 4 from over here, I must have gone up 3 inches, right? So this is 8 inches, and this is 3 inches. I'm going to use the Pythagorean theorem. Pythagorean theorem says 8 squared plus 3 squared is equal to my distance squared. 64 plus 9 is my distance squared. My distance squared is equal to 73. So my distance is equal to the square root of 73. Okay. I know that the square root of 73 must be somewhere between 8 and 9, because 8 squared is 64 and 9 squared is 81. I don't know that well, so I think I'm going to bring out my calculator again. Hopefully I can do this with this calculator that we have here. Oh my goodness. Let's see if we can figure this out. What is the square root of 73? Where is my square root button, or at least a power button? Let's give it a shot here and see what happens. 73 to the power 0.5. Isn't this sad? They actually pay me to teach. Can you believe it? Is approximately 8.5. That looks right to me, so I'm going to assume it's correct. Okay, so my answer is 8.5 inches. I hope this helps. I hope you study hard for your test, and we'll see you in class.